In tutorial 3 we will cover section 1.7 to finish chapter 1, and we will also cover the first 3 sections of chapter 2. We will finish sections 2.1, 2.2 and 2.3. Section 1.7 we will discuss linear inequalities and compound inequalities. So far we worked with equations. With an equation you have two sides that are equal. Inequalities are different, that you have one side that's larger than or equal to one side, or smaller than or less than the other side. Here is examples of inequalities. We will specifically work with inequalities that have linear terms. We call them linear inequalities. A linear inequality in one variable have one of these forms. Ax plus b is less than 0. Of course, here ax plus b, this is our linear term. Ax plus b is less than 0, or ax plus b is less than or equal to 0, or ax plus b is greater than 0, or ax plus b is greater than 0. And of course here domain normally, or the values for x can be any real number. To solve an inequality you want to find the set of values for x that satisfy the inequality. Before we start solving inequalities, we want to consider some of the properties for inequalities. In all these formulas, a, b and c are real numbers. The first one, if you have a less than b, then adding the same number to both sides will not change the inequality. So for any c, a plus c will be less than b plus c. Here c could be any real number, it could be positive, negative or 0. When you add the same number to both sides of the inequality, that does not change the inequality. Of course, you can add or subtract the same number from both sides, and you get the same, the direction of the inequality does not change. Now, what about multiplying by numbers? That depends on the sign, whether you have a positive or negative number. In this case, if you have c is a positive number and a is less than b, then a times c is less than b times c. Meaning if you multiply both sides by a positive number, the inequality does not change. You can also divide by a positive number, and you have a over c is less than b over c. Now if c is negative, then that changes the direction of the inequality. Assume c is negative and a is less than b, then a times c is greater than b times c. Here we started with a less than b, but by multiplying by a negative number, that changes the direction of the inequality. The same thing for division. We started with a less than b. If you divide by a negative number, you have a over c is greater than b over c. Of course, we considered these properties for less than and greater than. They also work if we have less than or equal, or greater than or greater than or equal. The same rules apply. Meaning you can add a number to both sides and the inequality does not change, or subtract a number. If you multiply by a positive number, the inequality does not change. The direction does not change. If you multiply or divide by a positive number, if you multiply or divide by a negative number, the direction of the inequality changes. Now, using these properties, we'll be able to solve inequalities in general. More specifically, we will look at an example of solving a linear inequality. the inequality we will solve is minus 4x minus 7 is greater than or equal to 9. طبعا we will be using the properties we just looked at. فwe'll start by trying to isolate the x term. Add 7 to both sides. We have minus 4x is greater than or equal to 16. Now divide by minus 4. Divide both sides by minus 4. And remember, when you divide by a negative number, you change the direction of the inequality. So we have minus 4x divided by minus 4 is less than or equal to 16 divided by minus 4. The left-hand side now becomes just x, so we have x is less than or equal to minus 4. This is our solution set. All x such that x is less than or equal to minus 4 is a solution for the original inequality. You can graph the solution set. This is the set of all points to the left of minus 4, and all x less than or equal to minus 4. So you can just graph it by starting with minus 4, include minus 4, and all the points to the left of minus 4. The solution set is x such that x is less than or equal to minus 4. If you want to write this in interval notation, this is the interval from minus infinity to minus 4, including minus 4. To solve different types of linear inequalities, we want to review the union and intersection of sets, because we will work with inequalities that have solution sets written as a union of two sets or the intersection of two sets. The union A union B for two sets is the set of elements that belong to the set A or the set B or both sets A and B. In example 2, the picture to the left shows the union of two sets. The union now will be all elements that are either in A or in B, or it could be in both sets A and B. The intersection A intersected with B is the set of elements that are common to both A and B. We are taking all the elements that are in A, and also at the same time they have to be in B. The picture to the right shows the intersection of the two sets. Then you have the set A to the left, the set B to the right. The intersection is the shaded area. It's the common elements that are common to both sides. All the elements that are in A, and also they are in B. Now, using the union and intersection of sets, we can solve more inequalities, where you will see that the solution set is actually the union or intersection of intervals. Here is that type of solution comes up when we work with compound inequalities. A compound inequalities, you have two inequalities joined together by either and. The two inequalities are connected by and, or you could use or. The solution set depends on how the compound inequality is written. So here is an example of a compound inequality where the solution set will be basically the intersection of the two solution sets for the individual inequalities. We want to solve two inequalities, 2x less than 6, that's the first inequality, and 4 is less than or equal to x plus 5. You solve them together, and the first one, if you divide the inequality by 2, you get x is less than 3, and for the second inequality, subtract 5 from both sides, or add minus 5, you get minus 1 is less than or equal to x. So our solution set is the two solutions set that we have joined by and. Our solution set will be all x such that x is less than 3 and x is larger than minus 1. We get the solution set will be then the half open interval. x from -1 to 3. Here -1 is included, and we use square bracket for that, and the point 3 is not included. Sometimes a compound inequalities can be written in one line, and it will imply you basically have two inequalities joined by the word and. So here is how we write a compound inequality of this form. Here we have a is less than x less than b, or you can say x is greater than b and x is greater than a and x is less than b. So again you have a compound inequality. If you write it this way, think of it as two inequalities joined by the word and. This is basically a less than x, that's your first inequality, and x less than b. You can solve such inequalities. Here you have actually three quantities. You have the left hand side, you have the middle quantity, and you have the right hand side. And anything you do to any quantity, you have to do it to all quantities. And the rules of addition and multiplication applies to both inequalities. We want to solve -7 less than x plus 4 less than or equal to 8, or think of it as x plus 4 greater than -7 and less than or equal to 8. But again, anything you do to one side, you do it to all sides. We want to isolate the x in the middle, but we would like to subtract 4 from each side. With subtraction, you don't change the direction of the inequality. So we have -7 minus 4 is less than, the middle part is x plus 4, we have to subtract 4. This is less than or equal to the right hand side, 8 minus 4. So the only thing we did here is we subtracted 4 from each side. The left hand side now is -11. The 4 cancels with the -4, so we have x in the middle, less than or equal to 8 minus 4 is just 4. So here is our solution set. The solution, or the values for x that satisfy the original compound inequality, are all x larger than or x is larger than -11 and less than or equal to 4. To write it in interval form, this is the set of all x starting from -11, from -11 to 4. The -11 is not included, the 4 is included in the solution set. So far we looked at compound inequalities joined by and. You can also consider inequalities that are joined by the word or. When you use the word or, you are taking the union of the two individual solution sets. Here is an example, example 5. We want to solve -3y is greater than 12, or y plus 7 is greater than or equal to 9. We are looking for all the values x that satisfy only one of the inequalities. It's possible that it may satisfy both inequalities, but we want to collect all the x that satisfy either the first inequality, 3y greater than 12, or satisfy the second inequality, which is y plus 7 is greater than or equal to 9. What we want to do is solve both inequalities individually and join the two solutions by or. For the first solution, the solution for the first inequalities, we want to divide by -3. -3 is a negative number, so we have to change the direction of the inequality. -3y divided by -3 is y. Greater than becomes less than, and 12 divided by -3 is just -4. This is the solution of the first inequality. Or when we subtract 7 from both sides in the second inequality, we get y is greater than or equal to 9 minus 7 is just equal to 2. Our solution set then is all y such that either y is less than minus 4 or y is greater than or equal to 2. Your solution set now is a union of the two solutions. Our solution set is an open interval from minus infinity to minus 4, union the closed interval from 2 to infinity. Next, we would like to solve inequalities that have absolute values. Before we do that, we need to review the properties of the absolute value. The first property, if k is greater than 0, then the equation, the absolute value of u equal k, is equivalent to either u is equal to k or u is equal to minus k. Yani if, for example, if the absolute value of u is equal to 5, then either u is equal to 5 or u is equal to minus 5. You have two solutions for such equations. What happens if k is equal to 0? Then the equation, the absolute value of u equal k, has one solution. It is equivalent to u equal to 0. The third possibility, if k is negative, then the equation, the absolute value of u equal k, has no solution. And this should be clear because the absolute value is always greater than or equal to 0. So the equation, the absolute value of u equal k, and k is a negative number, has no solution. The fourth possibility, if you have the equation, the absolute value of u equal to the absolute value of w, this is equivalent to either u is equal to w or u is equal to minus w. Using those four properties, we can work with both equations that involves absolute value, and also we'll look at inequalities that involves absolute values. Let's start with equations that involves absolute value. Example 1, we want to solve the equation, the absolute value of x minus 3 plus 5 is equal to 10. The first step is try to isolate the absolute value, so we will subtract 5 from both sides. We have the absolute value of x minus 3 equals to 5. And now we could use the first property. That means either x minus 3 is equal to 5 or x minus 3 equals to minus 5. We will have two solutions. The first one, x minus 3 equals 5. If we add 3 to both sides, we get x equal 8. For the second equation, x minus 3 equal minus 5. If we add 3 to both sides, we get x equal minus 2. Our solution sets have two numbers, 8 and also minus 2. And as usual, anytime you want to check the solution, since both of these are solutions, you can check if you substitute x equal 8 in the original equation, the left hand side will equal to 10. Same thing for x equal minus 2. If you replace x by minus 2 in the original equation, the left hand side will be equal to 10. Here is a second equation involving absolute value. The absolute value of 2x plus 3 equal minus 9. This has no solution because as we said, the absolute value is always greater than or equal to 0. So there's an equation that has no solution. Let's look at the third type of absolute value equations. We want to solve the absolute value of the equation, the absolute value of 2x minus 10 equal to the absolute value of x plus 2. For here, 2x minus 10 is equal to x plus 2, or 2x minus 10 equal to minus x plus 2. Again, you will have two solutions. The first equation, if we add 10 to both sides, and we have 2x minus 10 equals x plus 2, add 10 to both sides, and also subtract x from both sides. Our solution will be x equal to 12. For our second equation, 2x minus 10 equals minus x plus 2. We first simplify the equation. 2x minus 10 is equal to minus x minus 2. You can add 10 to both sides and add x to both sides and then divide by 3. You should get the solution will be x equal to 8 over 3. Your solution set now has two numbers, x equal 12 and x is equal to 8 divided by 3. Next, we will consider now inequalities that involves the absolute value. And here is the properties for inequalities with absolute values. This is the continuation of properties of the absolute value. Property number 5, if the absolute value of u is less than k, then we have u is larger than minus k and u is less than k. U will be between the negative of the number and the positive of the number. It will be greater than minus k and less than k. The property number 6, if the absolute value of u is greater than k, then either u is less than minus k or u is greater than k. Here just to remind you, k is a positive number. If the absolute value of u is less than k, then u is greater than minus k and less than k. If the absolute value is greater than k, then you use or. Either u is less than minus k or u is larger than k. You need to be careful because that will affect the type of solution you may get. Whether the absolute value is less than a positive number or the absolute value is greater than a positive number, that will give you different looking solutions. And before we look at examples of inequalities that have absolute value, just to make sure these facts work not just for greater than, less than, they also work for less than or equal and for greater than or equal inequalities. Let's look at examples, starting with example 4. We want to solve the absolute value of x plus 7 minus 3 is less than or equal to 4. The first step is to try to isolate the absolute value. We add 3 to both sides. We have the absolute value of x plus 7 is less than or equal to 7. Next, we want to use the properties of absolute value. That means x plus 7 is greater than or equal to minus 7 and less than or equal to 7. This is a compound inequality with using joined by and. To solve that inequality, we subtract 7 from each side. Minus 7 is minus 14. The middle part, when you subtract 7, you get x. The right hand side, 7 minus 7 is equal to 0. But here is our solution. All x larger than or equal to minus 14 and less than 0, less than or equal to 0. In interval notation, we have the closed interval from minus 14 to 0. Example 5, we want to solve the inequality. The absolute value of x plus 1 is greater than 5. Again, using the properties of absolute value, that means either x plus 1 is less than minus 5 or x plus 1 is larger than 5. The first inequality, we subtract 1 from both sides. We have x less than minus 6. Or the second inequality, x plus 1 is greater than 5. Subtract 1 from both sides. We have x is greater than 4. The solution set will be the union of the two solutions. either minus, we take the first solution set, which is the open interval from minus infinity to minus 6, union the second solution, the solution for the second inequality, which is the open interval from 4 to infinity. Of course, we have some inequalities that have either no solution, or some inequalities may be true for all real numbers. Let's look at example 6. The absolute value of 5x plus 6 less than minus 4 has no solution. That is because the absolute value is always greater than or equal to 0. This cannot be less than a negative number. The next inequality, the absolute value of 3y plus 9 is greater than minus 3. This is an inequality that's true for all real numbers because the absolute value is always larger than or equal to 0, so it will be larger than negative 3. This is the solution set will be the set of all real numbers. In chapter 2, we will look at the rectangular coordinate system. Basically, we will look at equations in two variables and see how we can graph them. We will look at the equation we'll be working with. We'll have two variables. You can graph them on the rectangular coordinate system. In particular, we will look at the equation of a circle and also the equation of a parabola. Both of these will be equations in two variables. We first need some definitions, and the first one is the distance between 2 points. We have 2 points. The first point is x1, y1. The second point is x2, y2. Just to remind you, this is a rectangular coordinate system, so we have two axes, a horizontal axis representing the x values and a vertical axis which represent the y values. A point has two coordinates, x1, which is the distance in the x direction or the horizontal direction, and y1, which is the distance in the vertical direction or the y direction. Here is our first point, x1, y1, and the second point is x2, y2. The distance is defined to be d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. You take the difference of the x values, square it, and then add it to the difference of the y value squared. You take the square root of that, and that will give you the distance of the 2 points. The formula is based on the Pythagoras theorem. This distance, of course, is always positive, and you can always use this formula to measure the distance between any 2 points on the rectangular coordinate system. The other formula that we will need is the midpoint between the 2 points. Now, if you can think of a straight line passing those through those 2 points, the middle point of that line, the line that starts with the first point and ends at the second point, the midpoint for that line, we can calculate the coordinates for the midpoint using this formula. M, representing the midpoint, is equal to the x coordinates is just the sum x1 plus x2 divided by 2. The y coordinates is just the sum of the y coordinates of the 2 points divided by 2. This is a point. The x coordinate is just the sum of the two x coordinates of the 2 points divided by 2. The y coordinates is just the sum of the two y coordinates, y1 plus y2 divided by 2. This is the formula that will give us the coordinates of the midpoints between the 2 points we started with. Let's look at examples to use the formulas. We have 2 points. The first point is -4 and -5. The second point is 6 and -1. We want to find the distance between the 2 points and also the midpoint of the line segments between them. The distance, we want to take now the difference of the x values squared. Then you take 6 minus -4 and square that, plus the difference of the y values, which is -1 minus -5, and that has to be squared. The first quantity is just 10 squared, plus the second quantity is just 4 squared. This is the square root of 116, which can be simplified to 2 times the square root of 29. That represents the distance between the 2 points. The midpoint, starting with the x coordinates, take the sum of the 2 x coordinates, and take -4 plus 6 divided by 2. That gives us the x coordinate. The y coordinate, add the 2 y coordinates, and take -5 plus -1 and divide it by 2. Simplify these numbers, you get 1 and -3. 1 and -3 is the midpoint of the line segment between the 2 points we started with. Now, how do you graph an equation? Remember, now we are working with equations that have 2 variables. You have each variable. You can graph the equation by selecting a few points for x and evaluating or calculating the y values, so you end up with points. Whenever you have an equation in two variables, you can always graph it using the rectangular system. Here the possible values for x, for example, could be an infinite set. You cannot graph all the points, but you can always select a few points, few values for x, and then for each value of x you can calculate y, so you end up with a limited number of points, and then you can try to graph the points and try to connect those points together, and that should give you an idea what the graph looks like. The more points you use, the closer you are to the actual graph of the equation. There are some points that are important to find the graph of an equation. We would like to see how we can find the x and y intercept. The x-intercept are those points where the graph intersects the x-axis. These are the x-intercept, so there will be points of this form, some value for x, and the y value here will be 0. And any point that where the graph intersects the x-axis, y will be 0. So this is the form of the x-intercept if it exists. It will be a point, a, and 0. The y coordinate will be 0. So that's one of the points we will try to find, is to find the x-intercept if they exist. Now, what about the y-intercept? The y-intercept are those points where the graph intersects the y-axis. Where you can find them by setting x equals 0, and substitute x equals 0 and solve for y. So these points will have the form 0b, 0 for x and some other value for the y coordinate. To find these, you must substitute 0 for x and solve for y. Let's look at examples. Here is an example of an equation: x equals y squared minus 4. To find, to graph, you can select few values. In this case, it's easier to select values for y and evaluate x. And once you have enough points, you can go ahead and graph those points, and then connect those points together and that should give you an idea what the graph looks like. For here, some of the values for y we selected 0 and some positive values 1, 2, and 3, and we selected some negative values -1, -2, -3, and these are values for y. To find x for each point, you just substitute it in the equation. For example, let's start with 0. When y is equal to 0, x is equal to 0 minus 4, so x will equal to minus 4. معناتها the first point is 0 and minus 4. For y equal 1, if we substitute y equal 1, you get 1 minus 4, you get minus 3. Let's look at some negative numbers. For example, if you substitute y equal minus 2, you substitute that in the equation. Minus 2 squared is just 4. 4 minus 4 is 0, for x is equal to 0. You can do that for each value of y that you selected. Just substitute it in the equation, and that should give you the value for x. If you look at the graph now, in the right hand side, here is the graph. طبعا we only graphed a few of the points. For example, minus 4 and 0, 0 and 2, 0 and minus 2. You can graph طبعا as many points as you want. If you connect the points together, you should get a graph that looks like the graph in the slide. Now, to find the x and y intercept, we can do this algebraically, by solving equations, or if you have an accurate graph, you can find it from the graph. Let's start with the graph. For example, the x-intercept is where the graph intersects the x-axis, and it is very clear that the x-intercept is just the point minus 4 and 0. So there's only one x-intercept. The y-intercepts, we have 2 points. You have 0 and 2, and 0 and minus 2. For the graph intersects the y-axis in 2 points. Now you should be able to find the x and y-intercept using algebra. For the x-intercept, and you start with the equation x equal y squared minus 4. To find the x-intercept, set y equals 0. If you substitute y equals 0, you get x is equal to 0 squared minus 4. It is equal to minus 4. Your x-intercept is then minus 4 and 0, which is the point we found on the graph. This is your x-intercept. To find the y-intercept, now you set x equal to 0. Again, start with the equation that you started with, x equal y squared minus 4. Set x equals 0. You have 0 equal y squared minus 4. Solve this equation, add 4 to both sides, you get y squared is equal to 4, or y is equal to minus or plus 2. So you have two solutions, y equal 2 and y equal minus 2. That means then the y-intercept is 2 points, 0 and 2, that's your first point, and 0 and minus 2, and this is the second point. طبعا you should be able to find the x and y-intercept using the equation, or if you already have a graph, you can find the intercepts using the graph. One more time, the x-intercepts are those points where the graph intersects the x-axis. The y-intercepts are those points where the graph intersects the y-axis. Section 2.2, we will cover circles. A circle is defined to be the set of all points in a plane that are equidistant from a fixed point called the center. In other words, we start with a fixed point, let's say with coordinates h, k, and look at all the points that have the same distance from the center. This distance is fixed. We call it r, or the radius of the circle. The circle will have, there's two different forms that you can write a circle, and we need to be able to work with both forms. The first form, which we call the standard form, you can get from the distance formula. Remember now, all these points x and y have a fixed distance from the center. Yani the distance, if you take any xy, the distance between xy and the center is equal to r. Using the distance formula and squaring both sides gives us a standard form for a circle that has radius equal to r and center equal to hk. The standard form is x minus h squared plus y minus k squared equals to r squared. Whenever you have the circle written in standard form, you can identify the center, hk, and the radius, which is equal to r. Let's take an example of the equation of a circle in standard form. We want to write the equation of a circle in standard form. The circle here has center equal to 3 and minus 1/2, and the radius is equal to 5. طبعا يعني to define any circle you need those two the two pieces of information you need to define a circle is the center, the fixed point, and the radius, which is the fixed distance. فهير طبعا we start with the equation for the standard form, and طبعا use the point, the center, and use the radius. The standard form is x minus h squared plus y minus k squared is equal to r squared. h here is طبعا these are the coordinates for the center. Replace h by 3, we have x minus 3 squared plus now replace k by minus 1/2, which is the y coordinates for the center. So we have y minus 1/2, and everything is squared, equal to the radius squared. طبعا the radius is equal to 5, so the right hand side becomes 5 squared. You can simplify this a bit. يعني here مثلا y minus 1/2 can be written as y plus 1/2. So our equation now becomes x minus 3 squared plus y plus 1/2 squared is equal to 25. Any point on the graph of this circle must satisfy this equation. And if you substitute, take any points on the circle, substitute the value for x and y, in the left hand side you should get 25. Now if you look at the equation in standard form, you can expand the equation and get a different form for the circle. The other form for the circle is called the general form. It will be a second degree polynomial in two variables. The equation in the form x squared plus y squared plus ax plus by plus c equals 0. This is an equation in two variables, and that will give you the equation of the circle in the general form. You can always, if you have the equation in standard form, just expand the equation, and that should give you the general form of the equation. The other way, if you have the equation in the general form, you should be able to write it in the standard form by completing the square. Here we have two variables, x and y. If you complete the square, if you start with the general form, complete the square for x and for y, that should give you the equation in standard form. And we will look at examples how to write the equation in standard form. The reason why you want to do this, of course, is if you write the equation of the circle in standard form, you'll be able to identify the center and the radius from the equation, from the standard form. Here is an example of finding the center and radius for a circle by writing the equation of the circle in standard form. In example 2, we want to write the equation in standard form and then using that form to identify the center and radius. The equation of the circle in this case in the general form: x squared plus y squared minus 12x plus 8y plus 5 equal to 0. The first step is to separate the x values and the y values, and to just in the left hand side just leave the variable terms and separate the x terms and the y terms. Any constant, any number, you can take to the right hand side. Here is my first step. I will write x squared minus 12x. Now leave a space to add a number. To complete the square, you're adding something for. Leave a space. Then plus y squared plus 8y plus leave another space to complete the square in y. The right hand side here is minus 5. Start now by completing the square. For x, take minus 12 divided by 2, you get minus 6. Multiply minus 6 by itself, you get 36. So you have to add 36. To complete the square in y, take the coefficient of 8y, and take 8 divided by 2, you get 4. Square that, you get 16, so add 16. Now you added 36 and also added 16 to the left hand side, so you have to do the same thing to the right hand side. The right hand side now becomes minus 5 plus 36 plus 16. And now you have both x and y are complete squares. For the x terms, you can write them as x minus 6 everything squared. Here the minus 6 is just the linear coefficient. Minus 12 divided by 2 is just minus 6. The x terms will become x minus 6 squared. The y terms are also a complete square. You can write them as y plus 4 everything squared. Plus 4 here is just half of the linear coefficient, plus 8 divided by 2. The right hand side can be simplified. If you add all these numbers, you should get 47. And remember now the right hand side is just r squared. Instead of you can write this as the square root of 47 everything squared. Now you have the circle in standard form. The circle have center equal to 6 and minus 4, and the radius is just the square root of 47. You are expected to be able to work with circles, whether they are in the standard form or in the general form, and you should be able to convert one form of the circle, from the standard form to the general form, and from the general form to the standard form. As we can see, you can do that by completing the square in x and y. In section 2.3, we will study the idea of functions and relations. Of course, a relation is a general idea, and a function is just a special type of relation. So we will start by defining a relation. Any set of ordered pairs x, y is called a relation in x and y. For a function in particular would be a type of relation. When you have a relation in x and y, the x values, the values you can substitute for x, is called the domain of the relation. The values for y is called the range of the relation. For a relation to be a function, there is certain conditions. Not every relation is a function. Given a relation in x and y, we say that y is a function of x. For each value of x in the domain, there is exactly one value of y in the range. There is two conditions here, that to have a function, for every value of x, every value in the domain must have a value assigned to it by the function. every value for x, there must be a value assigned in the range. The second condition is that you cannot have two different values for y for the same x. Yani every x in the domain must be assigned exactly one value in the range. فthat's طبعا an important يعني condition in every x in the domain must be assigned only one value in the range. Here is an example of a relation. يعني قلنا the relation is just any set of ordered pairs. So if you take the ordered pairs 8, 2, 3, 2, 9, 5, this is an example of a relation. طبعا this relation has only 3 ordered pairs. The domain is you take the first values of each pair. For the domain is 8, 3, and 9. The range, you take the second values. For the range has only 2 numbers, 2 and 5. This is an example of a relation. Let's look at a relation and see if it gives us a function or not. This relation now has the ordered pairs 4, 6, 3, 5, and 4, 1. This is not a function because if you look at the first and third pair, they share the same value for x, but different values of y. Yani this relation assigns 2 different values for the same x in the domain. Here 4 is assigned the value 6 in the first order pair, and in the third pair the value x equal 4 is assigned the value 1. فيعني 2 different values in the range for the same value for x. So this is a relation, but it does not define, يعني y is not a function in x. An example of a relation that does define a function is the relation that has the ordered pairs 3, 5, 2, 1, and 9, 0. Here, of course, the domain is 3, 2, and 9. The range is 5, 1, and 0. You see that for every value in the domain is assigned only one value, is assigned a unique value in the range. For that defines a function. Y is a function in x. We will see now how we can graph a relation. Of course, a relation is just a collection of ordered pairs, so we can graph them in a rectangular system. But you can also tell, we know that there is a difference between a relation can be a function, but every function is a relation, but not every relation is a function. So how can we tell that from the graph of a function? Let's look at 2 examples of graphs of relations and see how we can decide which one is a function. The one in the left, you can see the graph of the function. The domain here, any values, any real number can be in the domain, but the domain is minus infinity to infinity, all real numbers. The range, which is the y value, start at minus 4, and all the numbers that are larger than or equal to minus 4. But the range is the closed interval from minus 4 to infinity. Here is an example of a relation. This will give us a function, and the way you can tell that is from the graph is look at any possible vertical lines. A vertical line can intersect the graph in only one point, and that satisfies the condition for a function, because every value for x can have only one value assigned to it, one value of y. Every x in the domain is assigned only one value in the range, one y value. If you look at the graph of the relation in the right, first of all, this is a relation. The domain starts at minus 4, all the values from minus 4 to 4, x larger than or equal to minus 4 and less than or equal to 4. this is the domain. The range is all the values from -2 to 2. Yani y is larger than or equal to -2 and less than or equal to 2. Now you can easily take vertical lines, even if you take the y-axis, that intersect the graph in 2 points. Here, what that means is that you have the same value for x with 2 different values of y. For example, مثلا 0 and -2, that's your first point, and 0 and 2. The vertical line intersect the graph in 2 points. That means you have the same values for x assigned 2 different values of y. That means the graph of this relation does not define a function. طبعا the graph, the idea again to remind you, function is a relation, but for every x in the domain there has to be only one y. So we will see in the next slide how to decide whether a relation defines a function or not. But first, before we do this, let's see how to, suppose you have a function. So how do you evaluate a function for different values of x? طبعا we started with a function as a relation, so it's defined as a set of ordered pairs. But the other way to define a function is using a formula. A formula like the one in example 4, f of x equal 2x squared plus 3x. This is a formula, and using the formula you can define a function. For every value of x, the function assigns a value in the range that you can calculate from. طبعا f of x here is equal to y. The y values can be calculated from the values for x. That defines, this equation defines a relation, and this relation will be a function. To evaluate, to calculate the values for y from x, you just replace x by whichever value you want to determine the y value for. For example, if you want to know the y value when x is equal to 2, this is just f of 2. This is the y value for the function when x is equal to 2. And you calculate that by replacing x by 2 in the original equation that defines the function. So you get 2 times, replace x by 2, you get 2 squared, plus 3 times x becomes 3 times 2, and that should give you 14. When x is equal to 2, y will be 14. The ordered pair 2, 14 is in the relation that defines the function. You can of course evaluate any value, any number or an expression. For example, to determine what f of x plus 4 is, what you want to do in the equation that defines the function, you want to replace x by x plus 4. This becomes, we have 2x squared, so replace x by x plus 4. You get 2 times x plus 4 squared, plus 3 times x, replace x now by x plus 4, you get 3 times x plus 4. The next step you want to simplify by expanding x plus 4 squared. You get 2 times x squared plus 8x plus 16. Now for the second bracket, to expand that, multiply 3 times x, you get 3x, plus 3 times 4 is 12. Next, you want to multiply the 2 by the bracket and add similar terms. You should get 2x squared plus 19x plus 44. When x is equal to x plus 4, y is equal to 2x squared plus 19x plus 14. The next thing we want to do is to determine the x and y intercept. Again, if you have a function defined as a formula, f of x is just y. For any x, you want to evaluate f of x, and that will give you the y value for that particular x. Using that, just like we did with equations, to determine now the x and y intercept for a function, the x-intercepts are the real solutions for f of x equals 0. Yeah, and you set f of x equals 0. This is like setting y equals 0 to find the x-intercept and solve the equations. Yeah, in the equation that defines the function, set f of x equals 0, solve the equation, and that should give you the x-intercept. To find the y-intercept, you want to set x equals 0. In other words, you are evaluating f of 0. Let's look at examples for a function and see how we can determine the x and y intercepts. Our function here, f of x equal the absolute value of x minus 2. This formula tells me how to calculate the y value for any x. For any x, take the absolute value of x and subtract 2, and that will give you the y value, or f of x. Let's apply this procedure to find the x and y intercepts. First, we want to know the x-intercepts, so replace f of x by 0 in the equation that defines the function. F of x is replaced by 0. 0 is equal to the absolute value of x minus 2. Add 2 to both sides, you have the absolute value of x is equal to 2, or you have two solutions, x is equal to 2, or x is equal to minus 2. So now the x-intercept will be the 2 points, 2, 0. The second point is minus 2 and 0. Now for the y-intercept, remember we set x equal to 0, or just evaluate f of 0. F of 0, replace x by 0, you have the absolute value of 0, minus 2, you get minus 2. Okay, then the y-intercept will be the point 0 and minus 2. Now what about the domain? If the function is defined as a collection of ordered pairs, you can take the domain to be the first value from each ordered pair. But what about if the function is defined as a formula? The domain will be all the numbers you can substitute, and anytime you can substitute a number and you get something, you get a real number, and you get a number that's defined and is equal to a real number, then you can include that value in the domain. Starting with the formula, just see any values that you can substitute for x and you get a real number, then you can take that into the domain. That means not all the numbers will be in the domain. Given some functions, some numbers cannot be included in the domain because either they will give you an undefined value or they might give you a complex numbers. We don't want to take any, the y values cannot equal a complex number. It has to be a defined number. For a number to be in the domain, you must be able to substitute the value for x and come up with a real number. Okay, then which numbers we should exclude? In some cases, any x that will, if you have a rational function, for any value that will give you 0 in the denominator, will not, the result will not be a real number. Because you cannot divide by 0. For any x that makes the denominator 0 should be excluded from the domain. The other cases where you have to be careful, any x that makes the radicand negative with an even index root. مثلا if you have the square root of x, you cannot take the square root of a negative number, or the fourth root, or the sixth root. Anytime you have a radical with an even index, then you cannot take the value of a negative number, because that will give you a complex number. And remember, now we have to exclude complex numbers. We cannot allow complex numbers for the y value. These are the two cases where you have to be careful. Anytime you have a function that's defined as a formula, you have to exclude those two values. The values that will make the denominator 0 in the case of rational functions, and any negative value if you have a function that involves radical with an even index. Here are examples. This is example 6. If the function f of x is defined to be f of x equal x plus 5 divided by x minus 3. The value that makes the denominator 0 is x is equal to 3. But that has to be excluded from the domain. And you can use any real number with the exception of x equal 3, because that will make the denominator equal 0. The domain is then all of r except 0, or you can write it as a union of intervals, the open interval from minus infinity to 3, union the open interval from 3 to infinity. This is all the real numbers except x equal 3. The second example, g of x is equal to the square root of x minus 3. But you cannot allow the radicand to equal a negative number. So your domain will be all values for x such that x minus 3 is greater than 0. In other words, x will be larger than or equal to 3. So your domain will be the open interval from 3 to infinity, and all the numbers greater than or equal to 0. If you substitute any number in this interval, the radicand will be greater than or equal to 0. Then those numbers are all in the domain of G.